Hi everyone, welcome to Doc Hill's study where I help you get ready for your National 5 biology assessments. In this video we'll be walking through questions from an official SQA paper. The paper and the marking guide are both produced by the Scottish Qualifications Authority, the SQA, and all rights to that material belong to them. I'm using these resources strictly for educational purposes here on this non-commercial channel to support students like you in preparing for your exams. I'll be using the SQA's marking guide to highlight what answers are accepted, but keep in mind it usually only shows some of the correct answers and doesn't explain the reasoning behind them. That's where I come in. For each question, I'll walk you through the thinking process, explain what the question is really asking, and point out some of the common pitfalls to avoid. If anything doesn't make sense to you, or you want to ask about a specific point, feel free to leave a comment. I'll do my best to help you out. If you find this helpful, please give the video a like and subscribe to the channel so you don't miss any future walkthroughs. Let's get started. All right, here's question 4. Let's have a look. So, potatoes store sugar in the form of starch. Fair enough. Glucose 1-phosphate G1P molecules are converted to starch in an enzyme-controlled reaction. So glucose 1-phosphate molecules are converted to starch in an enzyme-controlled reaction. This enzyme can be found in potato extract. All right. So let's see. Glucose 1-phosphate. There's your basic glucose molecules, and they are converted into starch using an enzyme reaction. Very good. Okay, let's go on to the question and see what we can see. There is a tricky one down here at the end that we need to look at. Question A. Identify the type of reaction carried out by this enzyme. All right, well, we know two enzyme reactions. We know degradation and we know synthesis. Degradation is where a complex molecule is broken down into simpler molecules, and synthesis is where simple molecules are bonded together to form complex molecules. And so what we have here is simple molecules being bonded together to form complex molecules, so this is a synthesis reaction. Now you need to know that. Again, that's just flashcards. On my website, you can just use flashcards. No membership required, no fee, no nothing. You just go there and use the flashcards and enjoy learning. It's basically just doing that every day. You will learn it. There's no other way to learn things. Just do them over and over again until they're stuck in your head forever, right? Identify the substrate in this reaction. All right, so the substrate in this reaction is the reactant that is brought into the reaction and bonded to the enzyme's active site. And so the substrate and the product. So the glucose 1-phosphate is the substrate, the starch is the product, the substrate binds to the enzyme's active site and forms starch. Very good. Okay, so the substrate in this is glucose 1-phosphate. Okay, all right, good. Here's an experiment. An experiment was set up to investigate the time taken for starch to be produced. All previously made starch was removed from the potato extract. Okay, 2 rows of dimple tile were set up as shown in the diagram. Spotting tile, dimple tile. You may know them as different things, but they're telling you what the experiment does, okay? So GIP plus potato extract goes in here, and GIP plus distilled water goes in here, and each of these was tested after a certain amount of time. 0 minutes, 5 minutes, 10 minutes, 15 minutes, 20 minutes. Now, they don't ask you what that is, but it's a spot of iodine solution. We'll turn it black if there's starch present. All right. 5-minute intervals, the content of the dimples in each column was tested for the presence of starch using an iodine drop. The results are shown in the table. Here we go. Let's have a look at these results. So, time 0 in the potato extract one. Now remember the potato extract, we've been told up here, what is the potato extract? So, we were told this enzyme can be found in potato extract. Okay, so there's your potato extract. So the enzyme is in the potato extract, right? Okay, so we've got our substrate plus our enzyme, and here we have our substrate plus distilled water. This is our control, okay? So we should not expect to see anything here. and after 10 minutes we start seeing starch appear. So that's a fairly simple experiment. A little bit of time passes and starch appears. Okay, good. Let's have a look at what the next question is. Let's see. Suggest a reason. This means explain. Suggest a reason, you must give a reason, for any previously made starch being removed from the potato extract. Well, obviously, if we look at this, if we had some previously made starch, we'd get it at time 0, and we wouldn't see, this is a presence or absence experiment, so we need to make sure that there's no starch present in the starting reaction. So the experimental design requires no starch to be present in the at the start of the experiment, or that only starch made during the experiment is measured. Okay? So only starch made during the experiment and we'll have to say so that. Make clear that you're making an explanation, I think. Okay, so that only starch, it's a reason, made during the experiment will be observed, and it's observed by the spotting of it. Okay, it would be detected, observed, whatever. Okay, or to prove, you could say that to prove that the starch that we observe is made during the experiment. Okay, state 2 variables that should be controlled to make this experiment valid. All right, now we have a couple of words in here that are tricky. Variables that should be controlled, we have valid, this is talking about validity. Controlled can throw us a bit of a wobbly there really. We need to be careful about that one. But we're not talking about controls here, we're just talking about what variables need to be controlled. Okay, so let's just have a look at something. This is the course specification for biology, National 5, and they added this in 2022, and it's really important that you know the difference between these 3 words, okay? And they're in here, and I'm going to make sure they're in my flashcards, so go to the website and check that. A control is set up to compare results of an experiment where no treatment is applied. Now, we saw that in paper 1. That was where the little marble balls, or whatever it was, the little bits of marble were put in instead of the, what were the, maggots, I think it was. Okay, that's what control means. Okay, set up to compare results of an experiment when no treatment is applied. All right. Validity, and this is what we're talking about here. Validity, other variables are controlled to ensure that any effect is likely to be due to the variable being changed. Now, what's the variable being changed in our experiment? Well, it's time. We're waiting for time to pass. Finally, we'll just have a look at reliability. Reliability, we saw this in paper 1 as well, where consistent values in repeats of experiments are obtained. Now, they're asking at least one question about all 3 of these definitions to make sure you understand the difference between them in every exam. So you can guarantee it'll be in the 2025 exam as well. There'll be one question about controls, there'll be one question about validity, and there will be one question about reliability. This question, at least one, there may be more. This question is about validity. So we have to watch out for this word. 2 variables that should be controlled to make this experiment valid. All right, let's have a look at the experiment again. And sorry this is taking a bit of time, but it's a really important one to get our heads around and to get right. All right, what are we adding to this? We're adding a substrate and the enzyme in the form of the potato extract. Now, the potato extract is just pure mashed up potato as far as I can tell, or maybe mixed with a bit of water. So that's fine. Our substrate is going to be probably from a bottle of chemicals on the shelf, and we've diluted it out to be a certain concentration. Now, for this experiment to be valid, the concentration of the GIP must be the same in every well, and you must add the same amount, okay? Because if we increase the amount of substrate, we might increase the enzyme reaction. If we decrease the amount of substrate, we're going to decrease the enzyme reaction. These things are possible. So in order for this experiment to be valid, we want to have the same amount of and concentration, the same volume and concentration of GIP in every experiment. Same thing applies to this. We have the potato extract. This contains the enzyme. It also contains the right conditions for the enzymes. So the correct pH is already going to be in the potato extract. We're just adding potato extract to water, and we've removed the starch. So the starch has been taken out of it. So it's the only thing that's been done to the potato extract. So it's just potato extract dissolved in water. So again, same amount, same concentration. Now, we do have to be careful about pH, but because the potato extract contains whatever it is that's going to set the pH, that's all done with our concentration of potato extract. It's too generic an answer for this question. Temperature is also something that we need to control if we're going to repeat this experiment, because every time we do this experiment, we would have to repeat it in the same temperature conditions, because a higher temperature might go off the optimum for the enzyme and as a result change these results. But that's when we're repeating the experiment, not this particular experiment that they're talking about. So while it is important to control temperature and pH, and these are the answers that you might put down, and I think from the description of in the course report, a lot of students put either pH or temperature. The pH is dealt with by the potato extract. The temperature is dealt with by the fact that all of these things are in the same slide. All the reactions are going to happen at the same temperature. Okay, so it's very, very unlikely the temperature in this well is going to be different to the temperature in this well, or the temperature of these solutions are going to be different. Okay, so what we need to make sure is that the concentration and volume of the substrate is the same, and the concentration and volume of the potato extract is the same, and the volume and the concentration of the and volume of the GIP has to be the same. G1P in here has to be the same, and for distilled water. Okay, so let's get ourselves an answer for this. So what are we going to do? We're going to say volume. You could just use one of them because it's one variable. So the volume of the G1P solution. And you could say the concentration. It's a variable. So volume is a variable, concentration is a variable. Yeah. All right, you can't say pH, you can't say temperature for the reasons I've just described, but you could be talking about the volume of the potato solution and the concentration of the potato solution as well. It's got to be the same. Okay? Okay, let's move on. Explain how the results show that the enzyme is required for the reaction to occur. Well, again, here we are. So this is the second time this has come up. The control set up to compare the results of an experiment where no treatment is applied. Well, in our distilled water experiment, no treatment was applied to this because there's no enzyme in here. And that shows that the enzyme is the thing that has given the effect. So explain how the results, so what is the reason that we know? Explain means I have to give a reason. What reason? What is the reason that we know the enzyme was required for the reaction to occur? And the reason we know it is because there was no starch in any of the distilled. Let's get our spelling right. Doc Hill. Distilled water experiments. Or you could say there was no starch when the enzyme was absent. Okay? So, or you could say a positive one, starch was only produced in the presence of the enzyme. There was no starch in any of the distilled water experiment. You could just refer to it as the second row of the thing, but yep, that'll get you the mark. Okay, but it must be talking about we're also going to have to say that the activity, there was no starch produced We must put that in, okay? There was no starch produced in any of the distilled water experiments. Okay, there we go. That'll work. Get you the mark. Don't leave out produced. You must put it in. Okay, no starch made or produced. Thanks for watching this walkthrough from Doc Hill's study. I hope it helped you feel more confident about tackling these kinds of questions. Remember, the answers I've used are based on the SQA marking guide, but it's always important to understand the reasoning behind them, not just memorize the words. That's why I focus on the process, not just the final answer. If you've got any questions, or if something didn't quite click, drop a comment below and I'll get back to you. If you found this helpful, give it a like, and don't forget to subscribe so you'll be notified when the next walkthrough goes up. Good luck with your revision, and I'll see you in the next one.